Wang, ladies and gentlemen. I am very happy to have a chance to introduce the keynote speaker, Professor Pin Wang, to all of you. Professor Wang is chair professor at Washington University in St. Louis. Professor Wang just asked me not to introduce him, asked me to make a very brief introduction, since he would like to have more time to exchange ideas with all participants. And everyone can get his available information from the web. To save time, I will now let us cordially welcome Professor Wang to present his speech.
Thanks very much, Chin Chang, for allowing me to have a little bit more time to interact with you. Or if you really feel hungry, you can always say, I don't want to ask any question, why don't we go for reception? Okay. But right before the reception and the presenting after the beautiful talk of Jacques, it's never easy, of course. But I will try to do my best job to present this paper, essentially based upon a joint project with my co-author, Barak Urash. So the idea is actually very simple here. Okay. So if we think about the new misallocation literature, in the past decade or so, we have tons of paper talking about the consequences, the causes of misallocation, which is very important because it may actually affect a country's overall performance as well as individual firms or industries' performance. Okay, so if we think about the literature, right? As I mentioned, sometimes we think about misallocation in terms of, when I talk about misallocation, I focus on factor misallocation. So it could be on the capital side or on the labor side. Okay, sometimes you can also think about on the output side, there may be some wedges there also. But the issue is if you go really away from economic literature, think about the management science literature. I have a few projects, 3 or 4 projects, with different co-authors. We begin to think more seriously about whether this kind of production theory approach, more like reduced form type approach, whether it is appropriate to mimic the true behavior of businesses and the firms. Okay, so this has like a list of papers, joined with Chang Tai-Xie, the same co-author Barak Urash and the Jeff Lee, who is also here. So the issue is, in this management science literature, they emphasize a lot on how can you manipulate the factor endowment. Okay, so I'm using partly economic language, of course. Okay, and to manipulate, there are many different ways. One is just to rearrange, those capital, say machine. One is to try to reallocate the pairs between machine and the labor. Okay, so the second one is the one we are more familiar, which is the elasticity of substitution between the two factors. But the first one, which is really within the capital category or within the labor category, you can actually manipulate. Okay, and that has a term. Okay, the term since Hottaker, that is being called production techniques, basically. Okay, so our paper would be related to linking the two together. Okay, the flexibility measured by factor substitution and this production techniques. Okay, so we try to think about the following. Okay, these kind of techniques could be misallocated. So how important it is? Okay, well, if the technique misallocation itself may not be too important, whether that may interact with the standard factor distortions. Okay, and then the overall effect may actually amplify with each other. Okay, so we want to see what's happened there, and finally, how production flexibility measured by factor substitution may change the result. Okay, so totally 3 basic questions we want to address. Okay, so as I mentioned, there's a production technique literature there, but other than like a few papers, like the papers I just mentioned, and also another joint paper with Chong Yip and Russell Wang, most of the most of the papers here really treat these techniques as kind of given somehow. Okay, even they try to say they basically the purpose is different, right? So the purpose is you have random draw of those techniques, and then what's happened to the shape of the production function. So the questions are very different basically. Okay, so in this paper we try to indulgenize that and then to examine the questions we have proposed. Okay, somehow we have to link to overall performance of firms and the industry TFPs and the aggregate TFPs. Right? So this has something to do with, Ed, when he talked about TFP differences may depend crucially on the strength of the resistance to the efficient use of the currently operating technologies. You may think about our way of doing this is kind of similar to what he had in mind. I don't know whether this is exactly what he had in mind, but at least by reading the message in his lecture, okay, it seems to be relevant. Okay, so basically the emphasis is the efficient use of the currently operating technology, which we are going to call that one production techniques. Okay, so I think this is probably long enough, so I don't have to preview the result. Okay. So what we do here is we try to bring in this techniques choice. Okay, in addition to the standard new classical optimization, we allow firms to be heterogeneous, which is very simple, and we will also allow firms to enter in a standard monopolistic competition way there. Okay, and then we are going to look at the theoretical finding, and then finally we are going to quantify it to calibrate to the US data. Okay. All right, so here's the model. So we consider a lot of firms, they are very different, okay, and we are going to have a fixed entry cost, okay, and we are going to have a production decision, which will depend on both fixed cost and the variable cost, and everything's in all the costs here are in unit of labor, okay. By the way, I entertain any questions throughout the talk, okay. So please do not hesitate. Feel free to raise your hand anytime. Okay. Then we have to look at the stuff, and we do it in a particular way so you can easily compare with the new classical model. Okay. So in the first step, we solve a standard new classical model, and the second step, we are going to solve the technique choice. Okay. So the standard way of solving new classical model is minimizing cost subject to a production function. Okay. This is CES, but we will have properties different a lot by from standard CES function because of the indulgent choice of the techniques. Okay. So the standard way, you have capital labor ratio, which you can derive that, right? Which standard model just tell you capital labor ratio is inversely related to their price ratio, right? But here we have indulgence variables. We have indulgence variables of the techniques ratio there. Okay. Later we are going to focus on the case when rho is negative, which basically means it is in between the Leontief and the Kovlas. Okay. Because this is the case for all the US 2-digit industries. And so we can derive the unit production cost. Okay, so we call that one C tilde because we haven't solved AKAL yet. And so you can easily see this is a standard CES aggregator. The only difference is your capital rental will be divided by the technique applied to capital, and your wage rate will be divided by the techniques applied to labor. Okay, how you manipulate your employees, how you manipulate your machines. Okay, in one of my joint papers, the forward paper, we actually identified a number of cases talking about how much they can manipulate. And to your surprise, like a firm originally producing a notebook computer can be rearranged in a few months, less than a couple of months, and then to produce iPhone. That's tell you how flexible they are actually. Okay, but economists just ignore that usually, right? People say, you cannot change the machine once if you think about the standard particulate model, for example, then you cannot change it, right? But there are a lot of things which can be changed nowadays in a lot of industries. Okay, all right. So step 2, then we try to minimize the unit cost function we have just derived, and then to think about the technique choice. In the literature, usually the technique constraint is usually subject to a Covell's function, which we just follow. Okay, and this alpha is going to be crucial later. Okay, so just remember this alpha is the technique, the capital technique share somehow. Okay, and this z, the higher this z is, the more you can do to manipulate, and hence the higher your productivity will be. Okay, now we can solve the AK, AL, and we can derive the ratio. The ratio will turn out to be inversely related to, turn out to be positively related to the prices. Okay, so basically, if capital rental is more expensive, you want to reduce K, but then how can you still survive? You are going to manipulate K as much as possible. That's how you do it. Okay, all right. So you can just write the inverse A there, okay, and then you can find the equilibrium. This is the technique constraint, and this will be the you can say ISO cost function in a sense, okay, and then you pin down the optimal choice, unconstrained. So now the question is, what's happened, right? Okay, so if you get to the unit cost function, you will see this z there, but different from before, you will have much more complicated result there. Okay, but now what's happened? If the economy is not perfect, okay, say we have distortions. So just to save time, we are going to think about not 2 distortions on the labor side, 2 distortions on the capital side. Why don't we just focus on only the capital side? Okay, there are 2 different types of distortions. One is the standard capital funding or capital finance distortion. Okay, another one is the capital technique distortion. Okay, just 2 of them, both on the capital side. Okay, so this is the standard capital finance distortion, which will change the wedge. Okay, so the capital rental become this. So not surprisingly, this will discourage the capital usage if eta is positive, right? And increase the unit cost. Now the other distortion is the technique distortion. So if you restrict so we are going to focus on the first one only, okay? If you restrict only on the capital manipulation of the machine, then what's happened there? Okay. So we can derive a result which basically show you if you want to measure this distortion, which is kind of bad positive distortion, okay, then this technique wedge is positive if we have Pareto complementarity between the technique adjusted capital input. Okay, yes. Okay, so this will be totally different from adjusting the factor endowment. This this is due to the market distortion, due to any kind of, institutional issues, basically. But they are on two different sides, right? One side is basically if you want to finance, okay, say in China, public enterprises, SOE, can easily finance much easier than private sector, for example. But if you think about the technique side, okay, some sectors, some firms, they will face more difficulty in terms of manipulating this kind of machines than the others. So if you have distortions, informational distortions, it's hard to get to those parts, for example. So I would like you to think more of the conventional distortion as financial market distortion, and the second type more like the technique side is more like information distortion. Okay, I don't want to go through all the details, but the issue here is, oops, not here. Okay, the issue here is if you look at the unit cost, right? You won't be surprised either type of distortion is bad, right? So that's very standard. So you can see that result already, basically. Okay. So, but the interesting part is the production flexibility, the raw parameter. Basically, if you look at this cost here, any time when you see this capital market distortion, there's no raw anywhere, right? But whenever you see this technique distortion, you will see raw. Of course, you will also see alpha, but alpha will appear both. But you will see raw there. So that's basically tell you directly there is an interaction between factor substitution and the technique choice, and that interaction will actually change the technique distortion. But because there's no interaction there, so standard capital funding, capital market distortion will not interact with factor substitution. Okay, so that's very different, basically. Okay, so the standard independence based upon CES, as in many multiplicity competition model, which is also, the same thing here, basically. But although you allow for technique choice, things will be different. Okay. So maybe there's a way to break, what bother job there. Maybe I haven't worked on it, so I cannot claim it. Okay, so now you wonder whether this is amplifying or damping, right? So the result turns out to be if rho, as long as rho is negative, right? Then more flexibility, which means rho is closer to couplers, then the technique distortion, the negative technique distortion effect will turn out to be amplified. Okay, so essentially you can think about it in this way. When capital labor becomes more easily substitutable, okay, now you impose a constraint on capital distortion. Okay, now originally they can substitute quite easily, right? You should take advantage of that. But too bad you impose a constraint. That constraint is really bad, basically. Okay, if they could not be substituted, you impose a constraint. Not a big deal. Okay, so that's the intuition underlying the result. Okay, all right. And finally, you wouldn't be surprised the two distortional effects turn out to be reinforcing, okay? And that is crucial later for some of the findings there. Okay, now we have entry, and we solve the profit, and we solve the equilibrium. Okay, so once you bring the entry there will be also, in addition to the intensive margin I have talked about, right? Now there will be extensive margin because of entry. Okay. Remember before, flexibility doesn't matter if you have capital market distortion, right? But now, capital market distortion will also matter through the extensive margin effect because of entry. Okay, so quickly conclude. If we have capital funding capital market distortion, although there's no interaction with flexibility in the intensive margin, there is an interaction through the entry and the extensive margin. Okay. On the technique distortion, we have both intensive margin and the extensive margin. This is just standard TFP, Q, TFP, R stuff. One is the revenue major, the higher the worse, and the other one is the standard TFP major. Okay, so I don't want to go through the details there. So I want to put to the data, but before doing this, I want to quickly check, whether you got the basic idea there. Before I introduce you how to measure the TFP losses. Okay, all right, okay. We have done 2-digit, but we are reporting, what I'm going to report here is only the aggregated 1-digit manufacturer industry only. Okay. Okay. Now, how to calibrate? Well, we have to normalize the level of distortion, right? So you could normalize that one to be 1, -1, 0, or any number. So we normalize the distortions to be someone gaining, someone losing. So we normalize to be the aggregate average turn out to be 0. Okay. So this number will not affect anything, but we have to normalize the average level. Okay. And then we can back out the wedges from the data, which we do have compute stat data to measure the capital rental. Okay. And then we can back out this alpha share, which is very important. Once we back out this alpha share, industry specific, and then we can back out firm specific technique wedges. Okay, so the technique wedges come last. Okay. Lambda, no way to calibrate, and the capital income share wouldn't work because this is not capital income share. This is really more like techniques adjusted share. Okay, so there's no direct measure of techniques, and hence we cannot back that out. Sigma, the entry elasticity there, we cannot back out either. Okay, so this sigma is related to the markup basically. Markup ratio for different industries, all the estimates are really wide range. So we decided we just take the number from share cleanout. The main reason we cannot really back this out is because we do not have separate quantity and the price data. So the only paper I know with both quantity and the price data is actually my paper with Changtai and the GFD actually. Okay. So this is the problem. So in the US data we cannot really back out this. Okay. So we take that one as 3. Okay. And then later you will see this sigma equal to 3 will give you very nice result basically. Okay. Kind of nice, clean in a sense. Okay. Now raw is good enough because we do have a beautiful paper in Econometrica, Oberfield and the Roberts paper. So we have the estimates of raw. Okay. And I want you to do me a favor to remember 2 industries in particular. Okay. The most noteworthy industry is metal, including both primary and the basic metal and the fabricated metal. Okay. Did you see the elasticity of substitution is the lowest? Okay. It's very difficult to substitute between labor and the capital. And when we calibrate this alpha, namely the technique requirement on the capital side, the share is the highest. Okay. This share is the highest, and this is the lowest. So this is a very special industry I want you to remember. Okay. You may say this is pretty, this minus 1.85 is pretty low already, right? Not as low as metal, but pretty low already. But did you see a big difference between alpha? Right? This is pretty high. And this is one of the lowest, right? indeed the lowest in terms of the aggregated seven one-digit industries. Okay? Right. So this make a big difference later. Okay? All right. Now, how can we measure TFP loss? Okay. We assume all those barriers stuff, like the two barriers together follow joint log normal distribution. Okay. All right. So if we have that, firm productivity can be included there. Then we have log TFP of the industry, which can be measured based upon this equation. So let me just quickly walk you through. In share cleanout, what do they have? They have the average TFP of firms in the industry. Okay, so this is the first term in share cleanout. And the second term in share cleanout is you have the variance of log TFPR. The revenue major TFP, more dispersion will be bad. Because this dispersion is coming from distortion, basically. Okay? In share cleanout, that's coming from both factor distortion or one factor distortion, one output distortion there. Okay? So this is bad. But quickly look at the definition of this guy. What is the definition in share cleanout? Remember, there's no alpha. Okay? There's no techniques there. Okay? So in share cleanout, this guy is basically just the variance of this guy. Okay? So no alpha and the variance of this guy. Okay? So this is the standard literature, the share cleanout type stuff. Okay? All right. Now in our paper, what's happened? Because of the interactions between technique choice and the factor demand, the nuclear optical factor demand, we will end up with even the variance of TFP of firms matters. Okay? And the more variance, because of the log normal, we also have long tail there, right? So because of that, the more variance, the better, because you have the higher ones. Okay? So this is positive. Okay? And the inside of this variance of log TFPR, we also have a second term, which will depend on the technique distortion. But look at this. How important is this guy? Depends on alpha, right? If alpha S is very high, this will be more important. The standard capital market distortion will be more important. But how important is this technique distortion? Well, it will depend on rho. If rho is very close to 0, just think about one industry, okay, very close to 0. This is huge. Okay, so now I can quickly talk about based upon just this term. Okay, if rho is close to 0, it's more likely this technique distortion matter more. If alpha is very big, it's more likely the conventional capital funding distortion is more important. Okay, of course, the size of the dispersion matters too, right? The size of each distortion matters, but those will be calibrated. Okay, now turn to the last term. Remember when I say sigma equal to 3 is nice? Because I don't have to worry about the coefficients. Sigma equal to 3, 3 minus 1 divided by 2 is just 1. So you can ignore this totally, okay? Basically, you can ignore this term, you can ignore that term, okay? Now, all I have to worry about is 2 times the covariance between the two TFPR, TFPQ measures, basically. Okay. Whether this is negative or positive doesn't matter, right? Because if it is negative, then it's add positively to the TFPR. If it's positive, then it's actually hurt the aggregate industry TFP. Okay. So this is the whole measurement there. Okay. Any questions? Yeah. All right. Now look at the result. Bad news. Why? The conventional wedges are much larger than the technique wedges. So basically, the dispersion of the conventional capital market distortion, just based upon the size, it is much larger than the technique distortion. or whatever you want to call information distortion. The technology information distortion. Okay, so this is bad news, right? So potentially the conventional one is going to be more likely to be more important than the technical distortion. So this is bad news. Okay, this is like uniformly every industry. And when we do the two-digit industries, among the two-digit industry, only one industry this turned out to be more important, and you wouldn't be surprised. That is one of the precision industries actually. Okay, the whatever precision tools, whatever the stuff called. Okay, which is under the umbrella of electrical equipment. Okay. All right. So that's kind of bad news, right? Okay. Then we look at the contribution. Well, the contribution turned out to be totally reversed, right? Other than one industry, I ask you to remember which is metal, right? Other than metal industry, it's almost all the other industries, we have at least 3/4 of the variance of log TFPR is due to the technique distortion, not due to the standard capital market distortion. Right? Like 3/4 here, right? And the remaining are like 80%, even like 98%. Okay. So the only one which is not true is actually the metal. And this is because the metal industry calibrated the value of the alpha turned out to be the highest, which basically make the standard capital. So if alpha is very high, basically you already have a lot of flexibility there, basically somehow. Okay. Now if you have capital funding distortion there, which will dampen the play of this, huge input of this AK, the capital techniques. So that's exactly why, capital funding distortion becomes very bad, basically. Okay, so that's influence the log TFPR a lot. Now you may say why the paper printing is not as important. Well, still this is relatively low compared to other industries, right? This is mainly because this is not as high as 2.8, not as low as minus 2.85, and also because the alpha is one of the lowest indeed. Okay, that's why basically. Okay, but this is only log TFPR. So we haven't done the TFP yet, right? Okay, now look at TFP. Then we have to have the mean of the log firm level log TFP, and we have the variance of the TFPR, right? TFPQ, the TFP part, and the variance of log TFPR, which will contribute to log TFP negatively, right? And then finally, the 2 times covariance, which will also contribute negatively. Now, please look at the last column, okay? Second to last column here, okay? The covariance. Covariance turned out to be, other than 1, which is almost 0, all the other turn out to be negative. But the covariance is negative because the contribution is negative. So this interaction actually contributes to higher productivity than without it, basically. Okay? So by considering this technique choice, this actually contributes positively to the TFP. So conventional TFP major is likely to be under major somehow because of this covariance. Okay. Now turn to this guy, right? This guy, the worst one turned out to be food tobacco. And because of this, mainly because of this, the aggregate TFP is actually pretty bad. Okay. And the next worst one is chemical plastic, and this is this also explains why chemical plastic TFP is low. Okay, so quickly summarizing, for food and the chemical, the low TFP of the industry is largely driven by this dispersion of the revenue measure of TFP. Okay. Okay. Now, I want you to quickly compare metal with electronic, electrical equipment. Okay. Suppose we don't have the shear cleanout. Suppose we don't have technique choice, right? So of course this variance measure will be different too, right? But just quickly look. Just look at the electrical part, right? This is 2.01, okay? And you have to add this term there, okay? And this will differ, of course, right? But overall speaking, this number is going to be much smaller number than the metal one, basically. Okay. But with the technique choice, the aggregate TFP in electrical turned out to be higher than metal. So we have done a analysis of the case, without technique choice, and we find out in that case metal would be more productive than electrical. Actually. Okay, so that's hard to believe. Okay, and that has been discussed before, basically. Okay, there are people talking about, oh, we end up with this measure, but why this is the case, no one really knows somehow. But we basically say one possible reason is because of the indulgence technique choice. Okay. Okay. So this is the TFP. Now we can think about counterfactuals, right? To think about the overall contribution. Okay. So I want to do the counterfactual. Basically says, hey, suppose we have no capital market distortion. Okay. So everybody has equal access to the capital market. Okay. Then in this case, in our model with technique choice, you can see the percentage change of TFP will be like this much. So the largest one is like largest one by absolute value is like about minus 21%, right? And all the numbers are like between 0 and 20-something percent basically. Okay, so these are our model. Suppose we say we don't have technique choice. Go down to new classical, and we ask the same question again. See what's happened. Oops, the number turns out to be as large as 143%. Oh no, actually there's a larger one. Okay, 172%. Right? It's much larger, much larger. Okay, other than metal, right? So other than metal, paper printing, the two industries I ask you to pay attention to. They are just huge, huge. So this basically is the message delivered by the literature saying this capital market distortion could be very harmful. Okay, because if you remove it, you have a huge TFP gain somehow, and hence this is huge. Okay, but in our case, it's not that big. Still 20% change. Not small, but not a big deal compared with the technique distortion. Okay, so overall, if we do variance decomposition between the two, we find out technique distortion account for like roughly minima like other than metal. For all the others are 50 to 90% of the total. Yes, Michael. Yeah. Yes, I do. So a very interesting way to think about is to use IO table. Then I can have the forward linkage, backward linkage there, which we haven't done basically. Yes. 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 Yeah. If we have dynamics, the log TFP equation cannot be derived. we all know we have potential bias there, but it would become impossible to derive that equation. Yeah. Even in terms of standard, growth accounting, you throw in this K basically. But if you think about the endogenous accumulation of K, development accounting becomes also very, very difficult, if not impossible, basically. So that's a typical problem, in the whole literature of this kind of accounting approach, basically. Xun-Kun, when introducing Jacques, says, Jacques is always on the frontier. So maybe Jacques can build a model to tell us how to address that problem. But right now, it's really a big shortcoming of the entire literature. Okay. So don't worry, I'm far ahead of my time. Okay, so you will have your food very soon, basically. So you can ask many questions, as you like. Okay. All right. So this basically tell you, like, one reason this kind of capital market distortion, becomes, like a huge detrimental factor in TFP is probably because we don't have this balancing technique choice. If you do have technique choice, then you can balance out those, potential, the distortion. And the more flexible the industry is, or the firm is, okay, then the more easily you can balance out. Okay, so this is exactly why for the metal industry, when metal industry is not very flexible, technique choice will not be able to mitigate the distortion, from the capital market funding side. Okay, so that's what's happened basically. Okay, so I don't want to bore you with more results. This is the 50%, at least 50%, 50 to 90% basically. But lambda is definitely troublesome because we have no measure of that, and we choose lambda to be 0.5. So we have done lambda, to be different there, and we also have done, this theta to be in between, like 2.5 and 25% and 75%. Okay, so we have done all of the sensitivity analysis. The main message remains the same, and the very special industry of metal is still very special. Never changed there. Okay, so 2-digit industry, similar result basically. Okay, and finally, if we are willing to swallow the estimate of role for other countries, okay, the major is the U.S., right? But suppose we swallow this rule using the same rule for UK and Germany, then the result turned out to be very similar. So, which basically tell you it's probably some kind of institution in those developed economies which are somehow across the border somehow. Okay, and metal is hard to adjust between labor and the capital, and somehow the back out share of this technique stuff turned out to be pretty big basically. So you have to put a lot there in the technique adjustment in order to balance out the small elasticity of factor substitution, basically. Okay, so yes. Yes, yes. But when we do other countries, we use their input data, of course, right? So the only thing we assume, which is the same as the U.S., is rule, basically, because we don't have the estimates. But we use their input data, we calibrate everything. The result turned out to be very similar. We were kind of shocked, basically. Quantitatively, how important is the technique channel of course, the number changes, but it's always like, for most industries, the technique part is more important. So the qualitative message will not change. And also the spatial feature of metal will not change, okay? But the number does change, okay? All right, okay. So let me just quickly wrap up so we can have our food earlier. Okay, ignore all those sensitivity stuff. So basically, what we have proposed is to rethink about this production function, okay? And to allow for one more layer of indulgence choice, which is what we call the technique choice, okay? And when we do this, and then we link to the flexibility module, then we have a set of new results, which will tell you how important is the distortion from the funding side to the capital market, and the funding side to firms, okay, of the capital market, and also the other channel is through the technique capability, okay, which will be information based, okay, and then we find out this second channel turned out to be mostly for most of the industries turned out to be like very very important, okay, and the quantity is just huge. And when we ignore the technique choice, the message will turn out to be very different if we go back to the neoclassical model. Now you may think about, do we have any policy implication? Well, it all depends on how much you want to minimize the distortion, right? People always say we want to minimize capital market distortion to provide people equal access based upon the quality of the firm, right? Quality of the firm is crucial, of course, right? But we may also think about, if you think about R&D subsidies, like there are a lot of R&D subsidies are more like toward the product innovation, which is very fine, of course, right? But in terms of process, they can manipulate the machine. We should not overlook those. Those kind of manipulation of the machine become more flexible. Those are also very important, and those should be qualified for, standard R&D innovation. Currently, it's not. Okay, I mean, but those seems to be quite important, and so we don't want to say how big that could be. Okay, but at least based upon our paper, to minimize the technique distortion, that's maybe good policy actually. Okay, so I want to end the talk here to see whether there are more questions. Okay. So we want to have food earlier? Very good, okay.
Before ending this section, let us thank Professor Wang for his clear and interesting talk. I think the dinner is ready. So
I smelled food already.
So let's go to the lobby of this building to have a reception dinner. Thank you.